All right, good morning and happy Wednesday. It's December 6th, and I'm planning on doing the advent of code for today. So I'll share my screen. We'll start jamming here. Okay, so here we go. The 6th, 6:32 in the AM. We'll have to wait for it. Okay, oops. Let me open this gap here. Where do I want to go? We go to, oh, let's do this. Open this gap in VS Code. Then make a directory. A directory 06. Wait for it. Oops. Okay. Create these guys. 6:32 in the AM. Read the problem statement. Oops. This looks pretty important. We have 7 milliseconds, right? So what do we do with that 7 milliseconds? Zero is nothing, right? And that's stupid, right? 7 milliseconds, we use one of the 7 milliseconds to hold down. Hold for one, and then go 1 times 6, right? 6. Two, then go 2 times, it's 7 minus 1, right? 7 minus 1, 2, 7 minus 2, right? It's 1 times 6 equals 6. 2 times 5 equals 10. Right, these are the other options for 7, right? Hold for 3. Go 3 times 7 minus 3. It's 2 or 3 times 5, right? It's 15. 3, oh, it's only 12, it says. Oops, 3 times 4 is 12. Okay. 12. This calculation. Okay, hold for 3. Oops. Hold. Not hold. 4. Then go. Oops. So there's a bell curve to this. 4 times. Oops. This should be 12 as well, right? 7 minus 4 is 3, right? 4 times 3 is 12. Okay, so do hold for 5, it's the same as hold for 2, right? Go. I should be this thing backwards, isn't it? 5 times, oops, 5 times, right? You can see the pattern here. 7 minus 5 is 2, right? It's 2. It's 10. And the other one will be 6, right? It's inverted. Okay, so we only have to go up to halfway, it looks like. And it looks like halfway is probably the best option based on anecdotal evidence of the info so far. Anyhow, let's move on, right? That makes sense. So, I mean, the formula is this, right? When time equals whatever, here's 7, and x is how long we hold. And we want to maximize, right? Time that we hold multiplied by t minus x, right? This is what we want to maximize. So it's tx x squared x times t minus x. I guess I'm not sure if that helps or not. We want to maximize this and minimize that, I guess, right? So if t equals 7, and then x equals, say, 3, it's 3 times 7 minus 3, right? That works out, right? Similarly, t times x is 21 minus x squared is 9. Okay, and I get it, right? Second race, okay, yeah. Determine the number of ways you can beat the record. Four times 8 times 9. We beat the record of 7. 1, 2, 3, 4 ways. Seven and 9. This is the time, and this is the threshold to beat. Time and the threshold to beat. Okay, let's see what our input is here. It's pretty small, actually. Okay, so let's make sure the input works here first, and then we'll do the other input next. Right, make sure that toy input works. Time, distance. Okay, so it's 6:41. Check my time. Took about 9 minutes to understand the problem. Okay, so implementation begins. Should be able to just, game plan is just brute force. Try all holds from, it doesn't make sense to do 0, right? 1, 2. This doesn't make sense to do the whole target T. For each time and distance, consider all holds from 1 to time minus 1 to accumulate the winds would be exceeding the distance, right? It can't be equal to the distance, but have to exceed it. Right? You have to beat the record strictly greater than oops, dist. Okay, 642 will begin the implementation, right? Oops, implementation begins. Implementation, implementation, implementation. There you go. Begins. All right. So with open, oops, input, input for the line input. Oops. So for each line input, I guess we're gonna just take the two lines. First line and the second line. Fifth line that begins with, it's gonna be our time. The other one is distance. So put sub-zero. Sub-zero. I think this works or not. We'll just see what happens, right? Oops. Take the input like this. See what happens. 3 mains. Zero. No, it doesn't work. Okay. Open. This is input. How else do I want to read it? I want to read just 2 lines. Let's see. Let me look if I can find a more Pythonic way of doing this. Python 3. Read 2 lines from file. 2 lines at a time. What? I don't want that. Come on. F read line. F. Ah. Should be okay to zip it, right? That looks good to me. Time, distance, and zip input and input. That looks good. Let's do this. T and D would be our time and distance array. Okay. E in time split on the semicolons of 1 and dot strip. Actually, I'm not sure if we need a strip or not. We'll see what happens. Split it on 1. There should be a new line at the end here. Split it on 1 and then do split on that. Append. That's an integer. For distance in, do this. Distance split. Same thing, right? I guess we can create a function that'll get that too. Whatever. Do some refactoring maybe later on, right? Distance times distance. Well, that didn't work. D and T. There you go. Okay. Gotta save it before we run it. And so total for the part 1 be T. Oops. And so there's our total. Oops. Or T and D and zip T and D. So here we'll, oops, should T. This time and times, dist and dis. Just so it's a little bit easier. 4-letter words are okay, right? Time, dist. This guy time, this guy dist. And we can use T as our total. That'll be T1 and T2, part 1, part 2 correspondingly. Okay, so our time and our distance, time is T and X. Time and distance. No, I don't like this. Let's do this. Let's just call this guy part 1. I know there's going to be a part 2 as well. T, D, time, T, E. That's easier to read, right? Time and distance in each of these rounds. All right, so we just create a function that does this calculation, right? Or actually, we can just do this in for candidates in range from 1 to the time, not inclusive. We're just going X. X will be our time. Or T minus X, right? X times T minus X. What do we call these things? We call these things points or record distance. Target distance, we want to if X times T minus X strictly exceeds the distance, then it's a win. Wins when plus equals, just cast that predicate into an integer, so it's either 0 or 1. So those are all our accumulated wins. This guy, let's just do this pythonically, right? Just take this guy, if that guy, right? Here's our predicate. It's the amount of wins. Wins multiplied, wins multiplied together. Hold on. Let's do this. Right, so then part 1 equals reduce wins wins not pinned. That's how many wins we have, right, per session, and then the wins will reduce, right? Part 1, just call it T1 is fine. It's outside of T here, right? Yeah, it's kind of close. T and T1 are pretty close. All right, part 1 is fine, right? So it's going to be reduce. What is it from Func Tools? Func Tools, import reduce. All right, and then import operator. Operator dot multiply. And we'll reduce our bins by multiplying them all together, right? Okay, let's see what happens here. 288 seems plausible. Let's see what happens. 288. Okay, it's too low. 654. 288 is too low. Okay, so what did I do wrong? Let's see what we got here. Oh, oops, 288 is actually for the sample input, right? Oh, okay, so that's right. Okay, so actually I want to do this input. Okay, so that was right for the wrong input. Okay, let's try this again. 50,000. Okay, that's bigger than 288. Yay! Wait. Oh. 21 seconds. Okay. We'll wait 21 seconds and see what happens. I thought it was a shorter bit of text, so usually it's like 2 lines when it is accepted. At first, I thought I actually got it, but all right, we'll wait 20 seconds and try again, and then we'll go to Q2. As long as it works okay. Try this again. Yay. Okay, so that worked. 655. 65. This one. Oops. Oops. This was the sample input, which produces correct output. Yay. Okay, so 655 is accepted. Accepted part 1. Start reading part 2, 656. Read problem statements. Oops, statement 2. Okay. Learning. Fundraise, huh? That times that times that, or oh, it's actually concatenated. Single race. If y'all can tell or not, but the heathens have woken. The mob is awake. Right. Then yeah, these guys are going to be gigantic for part two. Right, so this turns into the concatenated value. Oops. This is the time we have. The distance we have to travel. Let's see how big these numbers are. The three, so these things are gigantic. Okay, so this is 49 million. This is billions and this is trillions. So we know it's symmetric or based on incidental evidence, and that seems to make sense. Maybe I need to just do binary search. I guess so. Part two, binary search. Okay, so we basically want to find the point where we start winning. Logarithmic time, right? Since it's linear time for 1 trillion input, right? Will definitely take forever. Right? Pretty sure we can binary search this thing. Okay, so as it fails, it fails, it fails. Okay, it succeeds and we'll go back, right? And then it's symmetric around that pivot, whatever the pivot in the middle is, isn't it? I think so. I think that'll work. I'm gonna take a break because I want to spend some time with my kids before they go to school. And then maybe just think about this more. I'm pretty sure binary search is the way to go, right? How else can we do this in a reasonable amount of time, right? So to do part two, we will try binary search to find the point where failure, right, where they start succeeding, right? So the bell curve is going to look like this. It's going to be like fail, 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 and then pass, right? So it's false, right? We don't beat it, and then we do beat the threshold, and then it'll be false like this, like bell curve. Bell curve. It's this guy, right? Basically, we want to find, goal is to find this point, right? Where we start passing and drive. Search, find this point, which we use to derive the answer to. Let's see where our bell curve starts. We know it's symmetric, so it'll end at the same spot, and that'll tell us how many we have for giant input. Thousands, millions, billions, trillions, and it's 1,000 trillion, right? 1,000 trillion is something gigantic. Comes after trillion. Comes after trillion. Quadrillion. Okay. That doesn't sound real, but all right, I'm gonna come back and jam on this later. Let me see y'all.